Hello everyone and welcome to a new unit for AP Chemistry. This is Solubility Equilibrium and I am Mr. Regan. That is me right there. Please follow through as I go through exercises 1 and 2 on page 3 of the NIMSY packet on Solubility Equilibrium. What we are talking about in this unit is how certain solids will dissolve when put into water and how they will reach a certain point when they won't, because there's been too much solid that has tried to dissolve and the solution can't handle anymore. So what we're looking at here is that in this first example we're looking at lead 2 chloride dissolving to a slight extent, and we notice that we have here a 1 to 1 to 2 ratio between the lead 2 chloride and its ions. And we also notice that there's going to be a solid here. Okay, so the solid, when we're writing our K equation, like we did for last time, for the last unit, this time we're going to write KSP though. We still write the products over the reactants, but because there's no aqueous or gaseous reactant, it's just going to be the products raised to their coefficients. I apologize for messing that up. Cl minus squared, looking at its coefficient, times Pb plus 2. And so that's our KSP value. If it asks us to find this value when we're given concentrations, we simply plug it in. So we need to know that we're looking at the lead ion concentration here, and that if this lead ion concentration is X, then the Cl minus must be 2x based on our coefficients from the balanced equation. And you can see that down below they input these values down here. So the 1.62 times 10 to the negative second is your Pb plus 2. They doubled this. 1.62 times 2 is 3.24. And we also squared it. So remember, we have to square this value and we get a KSP value equal to 1.7 times 10 to the negative fifth. And we can discuss what that value really means, whether it's really soluble, insoluble, in class. Let's take a look at this next example. In this case we have copper 1 bromide, knowing that that 1 is Cu plus 1. Bromide is Br minus 1. And so that will form your solid of CuBr, which breaks down into your Cu plus and Br minus. And this is your solid. If we want to come up with a KSP value, we need to have a formula. So KSP equals 1 to 1 to 1 ratio. So KSP is equal to concentration of Cu plus Br minus, nothing squared up top there. So we have 2.0 times 10 to the negative fourth times 2 times 10 to the negative fourth is equal to your KSP. Simple as that. Yes, you can put this into your calculator, but I want to start getting used to mental math. And so let's multiply the first numbers. 2 times 2 equals 4. When you are multiplying exponents, simply add them up. So negative 4 plus a negative 4 equals negative 8. And you're looking at 4.0 times 10 to the negative 8th equals your KSP. Moving on to the next problem. If we want to calculate the KSP from solubility for the second type, we are given, in this case, a more challenging compound, bismuth sulfide, and we can write that bismuth sulfide, 2s3, which is a solid, will break down in solution into two ions. Here we have to reverse switch, lose, and drop. So we know that the Bi should be +3. Positives are always first, plus S minus 2. The thing we can't forget to do here, though, is that we need to balance this. So I have 2 BIs and 3 S's. Moving along from here, we want to set up our KSP. So KSP equals Bi plus 3 squared, remembering its coefficient, times S minus 2 cubed. And if we know that we have a value of 1.0 times 10 to the negative 15th moles per liter for bismuth sulfide, so this value here corresponds to our bismuth sulfide. And if we want to think that our ratio here is 1 to 2 to 3, then my value for the bismuth ion should be twice the amount of the solid, and for the sulfide ion it should be 3 times the amount of the bismuth solid. So I can now include that. So this is going to be 2 times 1.0 times 10 to the negative 15th squared times 3 times 1.0 times 10 to the negative 15th cubed. Quickly rewriting, this is going to be 2 times 10 to the negative 15th squared times 3 times 10 to the negative 15th cubed. This one we're not going to do any mental math. It's a little trickier than the last one, and so we plug this into our calculator, and KSP is going to equal, with two significant figures, 1.1 times 10 to the negative 73rd. That is very insoluble. If you continue to want to watch this type of video, I have another mental math problem following this. If not, you can stop recording and move on to the next video if you need help. So our mental math practice problem is the breaking up of barium chloride solid into its respective ions. In this case, we know that the chlorine minus ion is 4 times 10 to the negative 3rd molar, and I want to know what the KSP value is. So if we want to take a look quickly, the work is shown on the next page, but if you want to do it on your own, please skip ahead and we will show it on another slide. So here we go. We can know that the barium chloride will break up into, so BaCl2 solid breaks up into Ba plus 2 plus 2Cl minus with a 1 to 1 to 2 ratio. Our equation is going to be KSP equals Ba plus 2 Cl minus squared. And I know that my Cl minus is 4.0 times 10 to the negative 3rd. And if this is 2x, this must be x from what we said up here. So that the value for Ba plus 2 must be half as much, so 2.0 times 10 to the negative 3rd. We can then get this solving and set it up a bit better. So KSP equals 2.0 times 10 to the negative 3rd times 4.0 times 10 to the negative 3rd squared. I'm going to move on to the following slide so that we can rewrite this and have a little bit more room. So our KSP equals 2.0 times 10 to the negative third times 4.0 times 10 to the negative third squared. I can break this up a little bit knowing that 4.0 times 10 to the negative third squared can be rewritten as 4.0 times 10 to the negative third times 4.0 times 10 to the negative third. So equals 2.0 times 10 to the negative third times 4.0 times 10 to the negative third times 4.0 times 10 to the negative third. We can pull out the front numbers and just multiply those together. So we know that 2 times 4 times 4 equals 2 times 16 is 32, or 2 times 4 is 8 times 4 is 32. And we can then say that 10 to the negative third times 10 to the negative third times 10 to the negative third is just the addition of exponents. So we have times 10 to the negative ninth. 3, negative 3, plus a negative 3, plus a negative 3 gives you negative 9. And so if we want to just combine them together, we get 32 times 10 to the negative ninth, which is equal to, in correct scientific notation, 3.2 times 10 to the negative 8th equals my KSP. If you have any questions, please email me. That is exercises 1 and 2 on how to determine the KSP value when you are given concentrations, making sure that you follow the ratio from the balanced equation. Thank you. See you soon.